Alright, so I think this is recording. Let's take a look then at this one. Um, they want us to state all the possible rational routes. Um, and even, for this one, we know how to factor it already, but without using the rational root theorem, but I'll show you that in just a second. So my constant term is negative 64, and I want to look at the factors of negative 64, the integers that divide 64. So 1, 2, 4, 8, uh, 16, 32, and 64, I believe. Hopefully I didn't miss any. Alright, the factors of 1 are simply, 1 and negative 1. Now, my list, this guy is my possible, these are my possible numerators, these are my possible denominators. So my list, and it's important to recognize that it's not the roots, that it's not the zero, it's the possible zeros, and it only is for rational zeros, not irrational. Alright, so this list is positive or negative. When that leading coefficient is 1, the factors of 64, we just repeat this list, because you've got 1 divided by 1, then 2 divided by 1, and then 1 divided by negative 1. You just get this same list. Alright, it's kind of bad looking. There. Now let's come in and check. And here, I'm not going to do synthetic division because I'd have to put in a 0x cubed. It's going to be easier for me to just plug these numbers into this equation and see if it equals 0. 1 doesn't work. 2 to the 4th power is 16, and 16 minus 64 is not 0. 4 to the 4th power, no, because 4 to the 3rd power is 64, right? 4, had it said 4 to the 3rd power, but 4 to the 4th power, it's like 256 maybe? Yeah, see, it's too big. 8 to the 4th is going to be too big. All the rest of these are too big. So none of these, so, check. So, we have no rational zeros. Now, we're not saying that this doesn't cross the x-axis. We're just saying that it won't cross the x-axis at a rational number. Now, let me show you that we can factor this, because we can look at this as a difference of squares. This x squared is x to the 4th, and 8 squared is 64. So I have x squared plus 8 times x squared minus 8. So I agree with this now that I see it in factored form, because x squared doesn't provide any real roots. They would be imaginary, because we would have to go to the set of imaginary numbers for x squared to be a negative number. Now over here, if we go to solve this, we've got x is the square root of 8. That is an irrational number, and that simplifies to square root of 4 times the square root of 2, where the square root of 4 is 2. So I agree that here was our list. and none of these numbers in the list were a 0. So those are the only possibilities. There are none for this. And we even looked and found, we know that of these four, this fourth degree, that 2 of them are going to be complex numbers and the other 2 are irrational numbers. Alright, so I hope that helps.